Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which converts a BST to a tree with sum of all smaller keys. First, let us take an example. We perform a regular in-order traversal in which we keep track of sum of nodes visited. Let this sum be stored in a sum variable. The node which is being visited, we add that key of node to sum. Then we change the key of current node to sum. When a BST is being traversed in order, for every key currently being visited, all keys that are already visited are all smaller keys. Next, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 9, to add smaller function. So root will point to 9. Next, we take a sum variable and initialize it to 0. Now we pass the root and sum to add smaller util function. Since root is not null, we recurve for the left subtree first, so that the sum of all smaller nodes is stored. So we pass the left child of 9, which is 6, using a call stack. Hence, root will point to 6. Again, as root is not null, we further pass the left child of 6, which is null. So now root will point to null. Since root is pointing to null, we return to the previous call and resume execution for node 6. Now we update sum to sum plus root's key. So sum will be equal to 6. Next, we set root's key to sum. So root will be 6, which it is already. After that, we pass the right child of 6, which is null. So root will point to null. Since root is null, we return to the previous call. Execution for root 6 is over, and now we resume execution for node 9. We add root's key to sum, so sum will be equal to 15. We update root's key to sum, so 9 will be replaced by 15. Next, we pass the right child of our new root, that is 17. So root will point to 17. Again, as root is not null, we pass the left child of 17, which is null. So root will point to null. Since root is null, we return to the previous call. We update sum to sum plus root's key. So sum will be 32. Next, we replace root's key with sum. So 17 will be replaced by 32. Then we pass the right child of 32, which is null. So root will point to null. Since root is null, we return to the previous call. Execution for node 32 and node 15 is over, and we have the final tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.